Good morning. I hope everybody is fine. So, I'm here again to proceed further in the classes. On the last turn, we studied about screw gauge. So, how to take the least count, how to take the observation, how to take the proper measurement, we learnt. Now, I'm going to take simple pendulum. Now, vernier caliper and screw gauge were for measurement of length, and simple pendulum is for measurement of time. Okay, so we move to the further slides to see how is this done. Okay. Okay, so students, you must have seen the pendulum clock. So, it is based on the periodic oscillations of a pendulum. Now, we are going to study the principle of simple pendulum. Okay. Now, what is a simple pendulum? A simple pendulum is a heavy point mass. As you can see in the diagram, there is a bob. The material can be anything. It can be of brass, it can be of iron, but it is a heavy point mass known as bob, suspended from a rigid support by a massless and inextensible string. That means the string from which the bob is hanging is massless. As compared to the other things, the mass is very, very, very small, so it is taken as negligible. So it is massless and inextensible. That means it can't be extended. Whatever is the length is the length. It has no extensibility over there. Okay. So a simple pendulum is a heavy point mass bob suspended from a rigid support by a massless and inextensible string. As you can see in the diagram, there is a point of support, and from there this bob is hanging from a thread. Okay, so point of suspension, you can see the bob moving, and you can see the equilibrium position. You can see how the bob moves. Okay, so we go to the further slides to see how is this done. So we saw that if a small force is given to the bob, how the bob goes to and fro. Okay, now we are going to study some important terms related to simple pendulum. Okay. Now, as you can see here in the figure, there is a point of attachment or the point of support. There is a thread or the wire, and there is a bob. And in the second one, there the same thing is there, only a small force has been given to the bob, and the bob starts moving in fro motion. Now I have named the three positions A, B and C. B is the equilibrium position here. When no force has been given, it stands straight in rest position over there. Okay. When a small force is given, suppose the ball is brought to one extreme and from there it is left. So you have given force. You have brought the bob to one side and you have given force. Now the bob starts doing to and fro motion. So while doing to and fro motion, the bob starts from point A and goes to point B. Then further it goes from B to C. Then again from C to B. Then B to A, and again from A back to B. So here the first point which is to be seen is, what is oscillation? It is moving. No, it is oscillating. So what will be one oscillation? Okay. One oscillation will be the distance which it is moving from first B to A, then A to C, and then back from C to B. When it completes one complete motion, then it is said to be one oscillation. It was at rest at B. From B, we had taken it to A. Okay, so it goes from B to A, then A to C, and then back from C to B. This will be one oscillation. Please remember, when it is back to its original position after taking both the extremes, then it is said to be one oscillation. Okay, so according to the definition, one complete to and fro motion of the bob of pendulum is said to be one oscillation. Okay, now second thing we come to is, what is frequency? You have heard this word often, but still we will take this here. What is frequency? Now, number of oscillations which this bob executes in 1 second. Okay, in 1 second, how many oscillations this bob is taking, that will be the frequency of this bob. Okay. Okay, now next is time period. Now, time period will be time taken by the bob to complete one oscillation. Time period is to complete one oscillation. Some people confuse with frequency and time period. Time period is the time in which one oscillation is happening, and frequency is number of oscillations in 1 second. Please be clear with these two things. And the last one, amplitude. Amplitude is the maximum displacement to the extreme side from the mean position. That means if we are taking the bob from B to A, or if the bob is doing to and fro motion and to one side it goes till A and then it again comes back. From A it returns. So for that A will be its extreme position and BA will be the amplitude of this bob. So maximum displacement to either sides from the mean position will be known as amplitude. Okay, so if I say in definition language, the maximum displacement of the bob from its mean position on either side is called amplitude of oscillation. Now you must also have studied the relation between time period and frequency. They are reciprocal to each other. Now why are they reciprocal? I said if T is the time period of simple pendulum, then T is number of oscillations. In T seconds, number of oscillations will be 1. So in time 1 second, number of oscillations will be 1 by T, unitary method. And 1 by T is what? F, because it is in 1 second. So F is 1 by T. F is 1 by T and T is 1 by F. They are reciprocal to each other. We have studied this, but I revised. So we move to the further slides to see what we have next. Now here, children, I have a complete procedure of the experiment which you all are going to perform in the lab. Okay? Everybody will do this. And so, I begin with, what are the things required for us to do the experiment? The first thing is there should be a meter rule. There should be 1 meter thread. There should be a bob. There should be a stand to hang it. Okay. there should be a stopwatch and the adjustment as shown in the figure. Now what we have to do is we have to clamp the thread from the stand so that the position is fixed over there. It hangs from there. And the length of the thread should be 1 meter. That is why we have taken meter rule to measure the length of the thread. Okay. And there should be a bob which is hanging over there. So the apparatus is to be prepared like this, and the length of the thread has to be 100 centimeters in the first case. Okay. Now we have a stopwatch. Now what to do? These were the apparatus. Now what to do? What you have to do is you have to take different lengths at different time interval, and you have to see what is the time taken by the bob to complete 20 oscillations. Okay. This is what you have to see. What you have to do here with this experiment is you are hanging this bob. Now, first you have to take it with 100 centimeter, then maybe you change it to 80 centimeter, then maybe to 60, then 40, then 20, and so on. Okay, so you have to keep changing your length every time, and you have to give oscillations to the bob, and you have to see how much time the bob takes to complete 20 oscillations. That is why we have taken a stopwatch. The moment you give force to the bob and it starts moving, you will click on to the stopwatch, and the moment it completes 20 oscillations, you will switch off the stopwatch. Okay. Now, how to take one oscillation? I've told you, you have taken it to point A. From A, it starts moving. From A, it goes to B, to C, then back to B, then A. Okay. So you have to see how many times it is crossing the mean position. So you have to see when it is one oscillation. You have to see from B to A to C, and back to B. This is one oscillation. So you have to see how much time it takes to complete 20 oscillations. Okay. After doing this, we have to prepare a observation table, and we have to do certain calculations. Okay. Now how to do that? We are going to see it in the next slide. Okay. Okay, children. So we have the observation table here. Now we have the serial number. So the number of times you are going to change the length, you will come to this different serial number. So the first case will be with your 100 centimeter. You can begin with the smaller length, or you can take the maximum length as it is your wish. So first you have taken 100 centimeter, and then you begin with 20 centimeters. You first take the length as 20 centimeters and you measure the time for 20 oscillations. Okay. Now, next what you have to do here is, after finding the time for 20 oscillations, you will calculate it as time period. That time period will be 1 upon 20. That means time taken to complete one oscillation will be the time, whatever is the time you have taken, upon 20. So you will get the time period for one oscillation. Okay. Then further what you have to do is you have to divide the length by t square. Whatever time period you have to do, you have got over here, you have to make it square, and then you have to divide the length by this t square. Okay. So the last column is L by t square. So again I say you have to take a certain length, you have to give 20 oscillations, you have to see the time for 20 oscillations exactly. After doing that, you have to divide the time by 20 because you have to find out the time period, and after getting the time period, you have to square the time period, and then you have to divide it by length. Okay. After doing all this, you have to prepare a graph. Now let us see how to do that. students, you have to prepare a graph. Now, you have to take the length on x-axis and you have to take t square on y-axis. Okay. And as you have calculated the figures, so you have to take the scale. After mentioning the scale, you have to draw the graph for L and t square. Okay. T square to y-axis, L to x-axis, and you will draw this graph. After you have drawn this graph, you will see that this graph shows a straight line. And this proves that you have done the experiment correct. Okay? This proves that you have done the experiment correct. You have to find out L and t square graph. Okay? So this way your experiment will be complete. You have to keep in mind the least count of each thing, how many decimal places to put, what will be the unit which I have mentioned in my previous classes. Okay? So now we move further. So we have some factors affecting the time period of the simple pendulum. The first one is the time period of oscillation is directly proportional to the square root of its effective length. What does this mean? This means that if you take the length as, suppose you are doing the experiment and your length is 20 centimeters. Now, if you make the length 4 times, so 20 into 4 will be 80 centimeters. Okay. So if you make the length 4 times, the time period will become 2 times. Okay. So 2 square of 2 is what? 4, isn't it? So when you will take the length 4 times, then t will become 2 times. Okay, it will, if length is increased 4 times, t will increase 2 times. That means if length is something, t will be under root length. The increase in time period will be under root length. So as the length will increase, so the time period will increase, and what will be the relation? T will be proportional to under root length. Under root length, that means square root of length. Okay. So time period of the oscillation is directly proportional to the square root of its effective length. I think things must be clear. Number 2. The time period of oscillation is inversely proportional to square root of acceleration due to gravity. Okay. Now, the time period of oscillation is inversely proportional to square root of acceleration due to gravity. So T is proportional to under root L by G. Or in this case, you can say T is proportional to 1 by under root G. Okay. We need not go into the details of this. You will study in your later classes. Now, third is the time period of oscillation does not depend on material of the body suspended. So whether the bob is made of iron or is it made of brass or it is made of copper or any other material, it has no effect. And the fourth one, the time period of oscillation does not depend on the extent of swing on either side. So it does not depend on the amplitude. You can give any amplitude to it and the things will be the same. So it doesn't depend upon the mass or material of the bob, and it does not depend upon the amplitude. So these are 4 factors, and from the above 2 factors we will find out a formula. So we proceed to the further slide. So from the first 2 equations, the first 2 factors, we get this equation here. that time period is directly proportional to under root L by G. And to remove the proportionality sign, T is equal to 2 pi under root L by G, where T is the time period, L is the effective length, and G is acceleration due to gravity. Why have I written effective length L plus R? Here, the length of the thread will be taken from the point of support till the center of the bob. That means the radius of the bob will also be included in the length. Okay, so effective length, you have to calculate the diameter of the bob from vernier caliper or screw gauge. Okay, screw gauge you can't use, so you have to use the vernier caliper. Okay, so L will be effective length, that will be L plus R. Okay, so we move to the next slide. Okay, so we have a numerical here now. The simple pendulum completes 40 oscillations in 1 minute. Find the frequency and the time period. Now 40 oscillations in 1 minute. So time period will be, that means how many, what will be the time period for one oscillation? So it will be 1 by 40. Now 1 minute is 60 seconds. So 60 by 40. So time period will come as 1.5 seconds. Very easy. Now frequency, I have already told, it will be 1 by T. F is 1 by T and T is 1 by F. They are both reciprocal to each other. So 1 by T. So 10 upon 15. Y have 1 upon 1.5 will come as 10 by 15, and so it comes to 0.67 per second. Okay. Now we go to the next slide. Now the next question we have, a second pendulum is taken to a place where acceleration due to gravity falls to 1/4. G becomes 1/4 of the previous one. How is the time period affected, if at all? So G becomes 1/4. So T0 if I take is 2 pi under root L by G according to the formula. So T is equal to 2 pi under root L by G by 4. Okay. Now T is equal to 2 pi, 4 will come up above. So 4 L by G. And so it will become T is equal to 2 into 2 pi under root L by G. So T1 becomes 4 pi under root L by G. T0 was 2 pi under root L by G, and T1 after putting G as G by 4, it becomes 4 pi under root L by G. So that means T1 is 2 times of T0. So whatever time period we had earlier, now it becomes 2 times of that. So if it was a seconds pendulum, the time period will be 2 seconds. For a seconds pendulum, time period is always 2 seconds. Please remember this. Seconds pendulum time period is always 2 seconds. So now the time period will become 4 seconds. Okay. Now, in the last question we have, compare the time period of two pendulums of length 1 meter and 9 meter. Now, let us take the length 1 as 1 meter and L2 as 9 meters. Now, we know T is equal to 2 pi under root L by G. So we apply the formulas here. While comparing, we have to divide. So T1 upon T2 will become 2 pi under root L1 by G and 2 pi under root L2 by G. So 2 pi cancelled, G cancelled. Now we have T1 upon T2 is equal to under root L1 upon L2. So T1 upon T2 is equal to under root 1 by 9, which comes to 1:3. So you have understood how to go for the numericals. I'll give you some numericals also. You have understood the concept of simple pendulum. If you have any problem, please do ask me in the comments below. Thank you so much. Take care. Bye-bye.